Hey guys, welcome back to my channel. My name is N Tejas and I'm studying in Sri Venkateshwara College of Engineering, 3rd SEM CSE branch. So today's topic is Karnaugh Maps. What is Karnaugh Map? Karnaugh Map, or also known as K-Maps, provides a method to simplify the Boolean expression. They are used for minimizing the logic gates in the circuit. Here are three examples of K-maps. This is an example of two variable K-map. This is an example of three variable K-map. And this is an example of four variable K-map. Introduction to K-maps. K-maps use a visual approach to simplify the expressions. They can handle up to 6 variables efficiently. They can be categorized into SOP and POS. SOP stands for sum of products and POS stands for product of sum. These are the two forms in which the K-maps can be expressed. Simplifying Boolean expressions. The goal of simplifying Boolean expressions is to reduce the number of gates used in the digital circuits, which improves speed and efficiency. Sum of products, that is SOP example. Use the sum of products method to generate digital circuits. This method is often not optimal without further simplification. Let us see how the SOP problem is done. For example, we are given this truth table in which the binary terms vary from 0 to 1. When A and B both are 0, the output is 1. And when A is 0 and B is 1, we get the output as 1, and so on. So here the min term is YAB is equal to M of 0, 1, 3, which stands for if both A and B are 0, that is here A is 0, B is 0, we are getting the output as 1, which is here output is 1. And if A is 0 and B is 1, which is A is 0, this is 1, here we get the output as 1, which is this. Similarly, the other two also. Hence, we get the equation as y of AB is equal to summation of 0, 1, 2, 0, 1 and 3. Next, here A is equal to 1 and A naught is equal to 0. In SOP, the final equation is AB plus A bar A complement B plus A complement B complement. Steps to solve the expression using K-maps. Select the K-map according to the number of variables. Then identify the min terms or max terms as given in the problem. For SOP, put ones in the block of K-maps respective to the min terms. For POS, put zeros in the blocks of K-map respective to the max terms. Make rectangular groups containing total terms in power of 2 like 2, 4, 8 and so on, and try to cover as many as you can in one group. From the groups made in the last step, find the product terms and sum them up for SOP form. So now, let us look into an example of two variable K-map. The question which we have got is, simplify the expression A complement B plus AB using a two variable K-map. How do we know that it is a two variable K-map? Since in the equation we have only two variables, that is A and B, we get to know that it is a two variable K-map. Now, one thing to remember is when we have a variable with complement, it is taken as 0 and the variable without complement is taken as 1. So in this, A complement B will be taken as 0 and 1. Then in AB, it is taken as 1 and 1 since both are just variables without complement. So now we have to place this complement in this cell such that both are satisfied. That is, A complement should be 0 and B should be 1. So hence we should place this in this cell where A is 0 and B is 1. That is A complement and B. Next AB, that is 1 and 1. It will be in this cell. And the other two cells will be taken as 0 Now we have to group the prime implicants whose values are 1. We have to group them in such a way that they are in the powers of 2, that is 2, 4 and 6. We had learned 2, 4 and 8. We have learned this rule previously in this video itself. So we are grouping this in the group of 2. So if we take this equation as f, so we are taking this equation as f. So we are consider this equation is in a single column and it occupies 2 rows. So the column, first we'll consider the column. Since the column value is 1 and it is pointing to variable b, we are taking it as b plus, since the in the row it occupies 2 rows, 0 and 1, we should ignore if it is not similar. We have to take the variable into consideration only when both are 0 or both are 1. That is, if this is 0 and this is 0, only then we can take into consideration, or if both are 1 and 1, then we can take into consideration. So now, since the row is 0 and 1, it consists of 0 and 1, we cannot consider it. So the final expression after evaluating this equation a complement b and ab is f is equal to b. Similarly, we can do this for other types of k-maps, such as 3 variable k-map and 4 variable k-map. So now let us look into the advantages and disadvantages of using k-maps. Advantages: it simplifies the Boolean expression, it gives a good visual representation, it is faster than other methods, minimizes the errors, and can be used for more than 2 variables. The disadvantages are: it can be used for a limited number of variables, it requires skill, can be time consuming, not suitable for complex circuits, can be error prone. The common mistakes that occur while using K-maps are incorrect grouping of terms, missing terms in loops, failing to wrap around the edges of the maps. Conclusion: K-maps are powerful tools for simplifying the digital logic. They are essential for minimizing logic circuits in design. Thank you. That's it for the video. If you like the video, please do like, share and subscribe my channel.